Gibbs energy and spontaneity. Gibbs energy is a better parameter to determine spontaneity. Also we know delta G is equal to delta H minus T delta S. Okay. Now delta S total equal delta S surroundings plus delta S system. Okay, that also we know. Also we know delta S is equal to delta H by T. Okay. Now, at thermal equilibrium, what happens? At thermal equilibrium, the system is in thermal equilibrium with the surroundings. So, temperature of the system and surroundings will be same at thermal equilibrium. Okay. What about delta H or change in enthalpy? Increase in enthalpy of the surroundings. Increase in enthalpy of surroundings is equal to decrease in enthalpy of system. Okay, decreasing enthalpy of system. Okay, so at thermal equilibrium, what happens? Delta S of surroundings, we know that is equal to delta H of surroundings by T. T remains same in surroundings and system. So, this will be equal to minus delta H of system by T. Because increase in enthalpy of surroundings is equal to decrease in enthalpy of system. Now, we can substitute in equation 2. Delta S total will be equal to delta S of system. Instead of delta S of surroundings, we can write this minus delta H of system by T. Okay, or multiplying the whole equation by T, we will get T delta S of total equal T delta S of system minus delta H of system. Okay, and for a spontaneous process, we know delta S total is greater than 0 for a spontaneous process. So, this will be greater than 0. So, delta S of total is greater than 0 means T delta S of system minus delta H of system is greater than 0. Okay, and we know delta G is delta H minus T delta S. So, minus of delta H of system minus T delta S of system is greater than or equal to 0. Okay, so we got like this. Now, this is delta G. So, minus delta G is greater than 0, or we can write delta G is less than 0. This is the condition for spontaneity. So, change in Gibbs energy is less than 0. This is the case for spontaneity. Or we can write delta G must be less than 0 means negative. Then that process is spontaneous. This is an important condition for this spontaneity. Okay. Now, there is an important criterion for spontaneity. Let us discuss that. So, criterion for spontaneity at constant temperature and pressure. So, we already discussed delta. If delta G is greater than less than 0, that is first case, if delta G is negative or less than 0, the process is spontaneous. Okay. Next, second condition, if delta G is equal to 0, what happens? Process is in thermal equilibrium. Okay, thermal equilibrium. Now, third condition, if delta G is positive or greater than 0, the process is non-spontaneous. Okay. These are the different conditions for spontaneity. Next, effect of temperature on spontaneity of reactions. So, we know delta G is equal to delta H minus T delta S. If the value of delta H is negative and delta S is positive, what happens? This value becomes negative. So, spontaneous. If delta G is negative, the process is spontaneous. So, spontaneous at all temperature. Okay. Now, next, if both are negative, delta H negative and delta S negative. So, what happens? This becomes negative and this becomes negative. So, though at low temperature, what happens? This delta G is negative and the process is spontaneous. Okay. Next, both are negative. What happens? If the temperature is high, what happens? Negative into negative, positive. So, the delta G becomes positive. Delta G positive means it is a non-spontaneous process. Next, if both are positive, delta G will be also positive at low temperature. So, the process is again non-spontaneous. Next, if both are positive at high temperature, what happens? This value exceeds. So, this becomes negative. So, delta G will be negative. Okay, so this value is high and delta G will be negative. So, at high temperature, what happens? If both are positive at high temperature, the process is spontaneous. Next, what happens? If delta H positive and delta S negative, in that case, what happens? In that case, at all temperatures, delta G will be positive. Okay, so the process is non-spontaneous. These are the effect of temperature on spontaneity of reactions. So, from this, we can conclude that Gibbs energy is an important parameter to determine the spontaneity of different processes. Okay.